Why Jeremy did not join?
You can send a message to him personally or probably
Yes?
can send him a message or personal message.
Okay, yeah. Please. Okay. So did he respond?
Oh, you didn't.
Okay. Okay. Wait, Praveen, I'm getting a call from him. Okay.
Yeah.
Yeah, Praveen, let's start now. So in the last class, we saw the scaling, like how we can attach the load balancers, scaling, we did the virtual machine scale set. So now we'll see what are the managed services. Okay.
Yes. Yeah.
Okay. Mhm. Okay. Actually, I am in night shift for this week. I mean, for this month.
Uh,
So I'm not able to cope up with the timings. Otherwise, I would have not done this late.
it's okay. No issues. So whatever convenient for you will go back.
No. I'll do for now. No, I'm just saying that. Okay.
Okay.
Okay. So now
Which, yeah, which company you are working?
LTI, LTI Mindtree.
Okay.
Yeah.
Okay.
So So now we will speak about the managed services with a specific focus on the compute services or monitoring. So in the last class we saw how we can deploy the applications using VMs, but not in we just deployed a Nginx there. So but in the a DevOps. So we will just create the AKS cluster and then we will build our own Docker images and we'll push it to ACR and then we will write the pipeline jobs and then in that pipeline we will include the stage where it will pull the image from the ACR and deploy to AKS cluster. Okay, so now
Yeah.
we will see those applications. So we will deploy our own application there. So now, and also in the last class, we saw how we can scale them using scale sets and how we can load balance between them with the load balancing. So setting up all that and setting all that up is not easy. So how can we simplify that? Because you see there, every steps we have to do from our own. So that's what we would be focusing on this specific function. So it is all about do you want to continue running applications in the cloud, if you're running any application on the cloud, so if you want to continue it the same way you run there in your data center, or are there any other approaches? So before we start looking at the different approaches to run the application on the cloud, there is a little bit of terminology that you need to understand, that is infrastructure as a service, and then platform as a service, also called as PaaS, and the infrastructure as a service is also called as IaaS or IaaS, and software as the service or SaaS. So and next we have the serverless. So we will discuss all these now. So now first in the first step, let's uh, get started with IaaS, that is infrastructure as a service. So what is infrastructure as a service? Like using only infrastructure from the cloud provider. So you're not leveraging any other application or any other service from the cloud. You are just leveraging or procuring infrastructure from the cloud. A good example is using VM, a virtual machine, to deploy your application or your database, or when you are using infrastructure as a service, you are responsible for the application code or application runtime. So you are responsible for configuring load balancing, and you are responsible for configuring auto scaling, and you are responsible for OS upgrades and patching if you just take the infrastructure as a code, and you are responsible for availability and a lot of other things. So cloud is not going to help you in all this. If you are just choosing infrastructure as a service, means you are just procuring the infrastructure. The best example is the virtual machine. So you will get just the virtual machine, and you are responsible to run the application or to write any application code, and you are responsible to configure the load balancing, auto scaling. If there is any, you have to apply the patches or OS upgrades and availability. So all of them is in your hands. So you are responsible for a lot more things. So the cloud provider. Oh, 1 second. Okay, I'll just connect my laptop to the chat. Okay. So the cloud provider is only responsible for the physical hardware, networking, and the virtualization. And upon that, so whatever after that, whatever steps you have, whatever responsibilities you have to take care. And the way we set up the Nginx on the VMs in the previous section is a good example of infrastructure as a service. Means we have our own application, we created the application and we deployed it on those VMs. So I'll just consider another example. So let's say I would want to run a Java application. So what I can do is I can create a VM, and let's say I'm choosing the Linux as operating system, and I would need the runtime, which is Java. So let's say I would go ahead and install Java on the OS, and after that I would go and deploy the application. So I'm responsible for all this. Okay, so I am also responsible for configuring the load balancing. I'm also responsible for configuring auto scaling and any other changes that I would want to do on OS and the application runtime. All that the cloud service provider is providing me with is the virtualization around the hardware. So we can go into Azure VM and say I would want to create a VM. So this virtualization is provided by the cloud provider. Okay, so I have the networking, physical hardware, and the virtualization. So this, whichever is in the red color, so it is that is provided by the cloud, and we don't really need to worry about the physical hardware. But other than that, all the other things like are our responsibilities. You see, so the boxes which were in the navy blue or magenta or whatever it is. So you see those boxes, those actions are our responsibility. So this is what is called the infrastructure as a service. The next step up from the infrastructure as a service is something called as platform as a service. So over here, you would be using platform provided by the cloud provider. And like when you are using platform as a service, the cloud provider is responsible for operating system, including patches and upgrades and application runtime or auto scaling availability and the load balancing. So you are only responsible for configuration of the application and services. So you are responsible for the application code. Let's consider an example. I would want to use a platform as a service to deploy a Java application. So in that kind of situation, only the application configuration, application code will be my responsibility. What I would do is I would tell the cloud provider, hey, this is the code I would want to run, this is the configuration I need. Okay, so you go ahead and run it for me. So you don't really worry about anything else. You don't want to worry about the operating system upgrading patches, anything. So you don't want to worry about installing Java. You would want all of them to be taken care by the cloud provider. And that's where cloud providers provide a number of services that are classified as platform as a service. A very good example of PaaS is Azure Apps Service. So with Azure App Service, so you can easily deploy Java applications or Python applications or containers. You can easily deploy them to Azure with a few clicks of the mouse, and you get auto scaling, availability, load balancing, and you don't really need to worry about OS or application runtime. So there are also a number of databases which are offered as PaaS. So across different clouds. So consider the AWS, GCP. So there are different databases, different types of databases, that is a relational and the NoSQL databases, which are being offered as a PaaS. So with these databases, you don't really need to worry about how to ensure the availability of the database and how do you ensure that the database automatically scale. So everything is taken care by the Azure. So you just worry about creating your tables and you just worry about creating your data. Okay. So platform as a service offerings are not limited to compute and DB. You have a number of other platform as service offerings for queues, artificial intelligence, machine learning, performing operations like metrics, loggings, and things like that. So we will explore a wide variety of PaaS offerings in Azure as we go further in the course. So in the next step, let's start with one of the most important ones, which is Azure app service. So we will see how to create the apps service in Azure, which is a PaaS. So in this step, let's look at the Azure App Service. As we discussed earlier, Azure App Service is a platform as a service, okay, where that is offered from Azure. It is a fully managed platform for building, deploying, and scaling your web applications. So you can deploy web application REST APIs. So you can deploy mobile backends to apps service as well. So it supports a wide variety of languages like .NET, .NET Core, Node.js, Java, Python, PHP. So you can deploy application which use any of these languages and with a few clicks of a mouse. Okay, and you can deploy a highly available application to Azure Apps Service. So before you deploy an application to Azure Apps Service, an important thing that you need to choose is a app service plan. So you need to define the hardware or the compute resources that you would want for your web application. So there are a wide variety of plans that are available. So you need to choose the one which is right for your circumstances. So Azure App Service offers a number of services, that is automatic deployment and management and also it will take care of the auto scaling, and also we have built-in load balancing option. So we will see that in the next step in the Azure portal, like how we can create the Azure apps service. So we'll configure our first Azure web app using the Azure apps service. So do you have any doubt here?
No, no, no.
Okay.
Suppose in this backend, like the Oracle DB or something like that, so that all will be pre-installed when we order it, or we have to install it with the license or something.
No, no, everything will be there.
Okay.
Yeah. So everything you will get. So did he respond you, Jeremy?
No, not responding. Last week also he didn't join. I don't know.
Mhm. So I'm in my Azure portal now. So here I'll go ahead and choose Azure Apps Service. So just take Azure App Service. So I'm in my apps service now, and this is where we can go ahead and say create our first apps service. Let's wait. So like you want a web app plus database, or it is WordPress on app service, or static web app. So these are there here. So you can go ahead and choose whichever options you want. So So as of now, we will go with the a web app because we have not seen the databases still. Okay, so I'll just go with the web app. So I would want to create a web app. So I can choose this subscription, and coming to the resource group, I would choose the compute resource group, whichever we created for our this thing. So this is fine, compute RG. And then I would like to give a name to my web app. So the first thing that I would do is like I can give any name here. So I just give my first web app. This should be unique. Okay. So, and then what you are doing. So whether you are going with the uh, so whether you have your own code or you have any Docker container which you want to run here, or there is any static web app. So based upon the publish, what type of the publish you want. So web apps allow you to deploy code as well as Docker container and as well as the static web. So as of now, we'll just go with the code, and then we have to choose which kind of code you want to deploy. So you can choose which runtime stack you want, whether the .NET or Java. So I'll be going with the so you can choose whichever you would want to make sure, or you can make use of if you are make using of the Docker container, like you have to specify what is the operating system, and whether it is for the Linux or the Windows. So you have to make use of like you can uh, so if you have a pre-built Docker container which is available, you can make use of it and you can run it on the web app. So what I would do is I would make use of a Docker container for now, and I would choose operating system as Linux, and I would choose the region as East US. So the sometimes East US will not work, so I will go with the Australia. Australia's Central, so I'll go with this. Okay.
How about Indian data centers like Central India and those are not reliable?
Okay. Let me go with Central. Actually, I tried it. They told like the Azure told me that that region is not having quota or something like that, because I was in the free trials subscription at that time. Maybe because of that, it did not allow me to create the web app in the East US. Okay, you want me to try?
No. I just asking. Sorry.
Okay, so it depends on your type of subscription.
Okay.
Okay,
But
so
is there any latency, like for example, if for example the client is accessing from Bangalore or somewhere in India, and the server is somewhere in Australia or US, and instead the server is in Central India, is there any latency difference in that?
yes, there will be some latency based upon the distance. Okay, so if you have any caching service which can cache your uh, the content, like how we have the cloud front or the CDN in the AWS. Like if you have those type of service, then it will be easier for you here. Okay.
Okay.
So we will go with this central US and see whether it will allow me to create the here. So the okay. So you need to associate the plan, the service. I mean the apps service plan, and the app service plan, like it is for like what type of hardware you have used to run your application. So they will put the pricing for that. It decides the compute resources, the features, and the cost as well. And so what we will do now is create a new service app plan. Like we will go ahead and create that. So we would be using, we would choose the basic B1, and which is the default plan, which is suggested in here. So I'll just go with that. Okay. So here there is no SKU and the pricing. Okay, like I am fine with this plan. So let's see what type of it has, like what resources it will give us. So it is giving us premium. Okay, we don't want premium. We will go with the basic. Yeah, this is fine for us. Uh, so will this is fine for us. Basic B1. So we are not doing any prod workloads. Okay, so it decides the compute resources, features, and also now we have chosen the basic B1, which is the default plan, which is suggested in here. So I will go ahead and say next to the Docker. So instead of deploying a custom container, like as of now, we don't have any custom container. What we will do is we will use the sample which is provided by Azure, which is Nginx. So earlier we were deploying Nginx using a VM, and right now we are deploying Nginx again, but this time using the apps service. You would know how easy it is to use the apps service and deploy Nginx. Now what I will do now is go ahead and say review and create. Like you can say the options, like how many the container you want. It is a single container. If you are deploying multiple ones, so you can go with the Docker Compose. So single container is good. And then the image source, like from where, from like which is your uh, a registry from where you want to fetch the images. Like here, if is it a Azure container a registry, or the Docker Hub, or the private registry. So if you have any images in the Docker Hub, like if you just go to the dockerhub.com, where you will build the image and push it to the Docker Hub account. Like I have so many my own images here. So these are the different images I have. So whichever image you want, you can just take from here and pull it to your app service. But since we haven't done, because I haven't shown you how to build the image and push it to your own Docker Hub, how to create your own custom images. So I'll be just going with the quick start. So means we are just taking from the there is a a default one which we are taking. So now coming to the networking. So if you want to enable the public access, like you want to you want to have you want to have your users to access your app service, you can just say yes. You can go ahead and make your apps service public and enable network injection. So we will see this option in the virtual uh, networking. So when we do the virtual networking concept, that time we will see this. So now if you want to enable the monitoring, like any application insights, like it will monitor. So Azure Monitor Application Insights is an application performance uh, a management service for developers and DevOps professionals. So you can enable it below, I mean here, to automatically monitor your application. It will detect the performance anomalies and includes powerful analytics tools to help you diagnose issues and to understand what users actually do with your app. And also the bill will get generated for this. It is not free of cost, like it will, the amount will be generated based upon this. So I'll just say next tags, and then if you want you can give any tag. I'll just say review plus create. So a final a validation will run. So this thing is good. Okay, so I'll just go ahead and say create. Okay, the thing deployment is complete. And we'll just go to the resource now. And then here you can see, so you can see the overview of your web app. It is giving me error, disabling error, fetching health, check data. Please try again later. Hmm? Why? Okay, it is disabled. Okay, that's fine, completely fine. So the a web app which we created is running. So let's go in and over here, and you can see the URL. So here there is a URL. There is domain. So you can take the default domain and paste it in the browser. Okay, so it got successfully deployed. So your app's service is up and running. So this is coming from the default Nginx page. Okay, this page is coming from the Nginx of the Azure. So this is in Azure, the quick start. So they have built an image of this. And when I deployed it, so when I access that container, I mean the container is running on the app service, and then when I access the app service link or the endpoint or the domain, so you see, so whichever application is running in the container, it is getting displayed here. So you see, it is very easy to deploy the application using app service. You need not configure anything. You need not create the load balancing anything. It will just provide you. So this is the pass as a service. So similar to virtual machine, you will have the activity log here. So activity log you have here, where you can look at all the activity that is performed on this, like uh, uh, so it created the website, it did the update website. So you can see what are the operations you have done. So if you type scale in here, like either you can search for the scale. So you have this, the scale up and the scale out. So if you just want to scale up the things or the resources which is taken for this app service, you can just go ahead and do that. You can do the vertical scaling. So what is vertical scaling? It is increasing the existing resource. I mean, if you have like if you have one virtual CPU and 1 GB of memory, or a 1.75 gigabyte of memory, you can increase it to 5 CPUs. You, like, you're just using the same instance. In the same instance, you're just increasing the available resources. Like if you have 1.75 GB of RAM, then you're making it 5 GB of RAM. If you have one virtual CPU, you're making it 5 virtual CPU. So you're just increasing it vertically. So like let me take a paint. So before it was this much, but now you're increasing the resource. Now it is this much. This is vertical scaling. So what is horizontal scaling? So horizontal scaling is you have this. Okay, so you have your instance, and in that instance you have one virtual CPU, 1 MB of, I mean 1 GB of memory. So instead of like increasing this to like this, increasing these resources from 1 to 5, I'm just creating another instance of same like that. So the duplicate of this instance, where I will have another instance, a duplicate copy of this, and it will have the one virtual CPU, 1 GB of RAM. So again, I'm just horizontally scaling it. I'm not just increasing the existing resources, I am increasing the number of instances itself. So you're getting right.
Yes, yes.
So this is horizontal scaling, and this is
Just
a,
vertical.
a vertical scaling. Okay. So like this is where you can go in and you can increase the number of instances. So
Today, we are connected to CLI bash command for that virtual machine. So is there any way to connect to the container also same way? Suppose somebody want to modify some files or something.
no, as I said, it is everything managed by the cloud itself, so you will not have the access to the underlying things.
Suppose if any apps or something which is customized by the user, so we wanted to modify and implement it over the, so that also they have to do it or not?
See, if I go to the configuration, um, here, app service storage, the registry user, not this one, general. So, see, while so this is the Docker registry wherever the image is getting fetched. Okay, so if you have your own custom images, so how you can bring the changes for your here apps, the services. Here I have chosen the Docker container, and the Docker container. If you want to bring any changes there, so you have to make changes in the a, a Docker file of your images and build a new image, and then give the registry URL here. Okay, and then if you give the registry URL and specify the content, the image, that will get the fetched here. And then whatever changes you have made in your application through images, so those changes will be uh, brought up here. Are you
Yeah, I got it.
convinced?
Yeah.
So you can see in the deployments center, if you want to change anything, like the server URL, the registry source, so it is private registry. If you have your own images in the Docker Hub or Azure Container Registry, you can fetch from there as well. So you can give the full image name and the tag. So all these things are by default taken. So when I said the quick start, so all these things by default it has taken. So we will build our own image in the uh, DevOps part. So we'll build our own image and we'll push it to Azure Container a registry. Okay, from there we will fetch it. So since I haven't done that, so I'm just going with the a basic one.
Okay. Okay.
Okay, so I'll go to the scale out option here. Where is the scale out? So let's say I would want to have the two instances or the three instances. So let's say here the current instance is one, and the maximum scale instance for my subscription or for my current plan, I can have three. Okay, so more than that, I cannot go. Uh, so if you want to scale, you can scale out. So the manual. So here you can say I need two, like this. And so I would want to have two, and I would what I need to do is, so here it is manual scale. So in my pricing plan, that is the B1 basic, I can just go with the manual. So if you just go with the premium, like if you just change the plan, so going with the premium, so I'll just say select. Okay. So see, all the options are available now. So if you want to do the automating scale out method, so platform manage scale up and scale down based on the traffic. So how much based on the traffic, like what the user accessing your application. So based upon that, how many number of users, based on that, the instances are increased. So this is the, you can give the maximum burst, like how many instances you want. So, and you can give the always ready instances, so at a normal pace how many instances you want, you can give it here. So if you want to enforce scale out limit, like you can have maximum is you want to scale out up to 50 instances, more than that you don't want to go, like you don't want to go beyond that, so you can go with that. So if you want to do any rules based, say user defined rules to scale on a schedule or based on any app, a metric, like like the CPU utilization, memory utilization, the disk storage, based on that, if you want to do it, you can do. So as of now, we'll just go with the manual. So I'll just change it to basic one. Okay, it say I need 2 instances. I'll say save. So this would increase the number of instances to 2. So this is scale out where we can increase the number of instances. So in addition to scale out, you can also do a scale up, that is basically changing your underlying resources. If you have one virtual CPU, you can increase it up to 2 virtual CPU. And if you have 4 GB of RAM, we can increase up to 8 GB of RAM. Okay, so that is fine now. So in the hardware view, you will get like to what resources you want to scale, and coming to the feature view, like what environment you want to have for the dev or the test, or for the dev application or the test app environment, or for the production. And uh, so you can see the corresponding cost as well for that. Okay. So this is common across most platform as a service offerings. Like you cannot access the VM which are present underneath. So you cannot whatever the services managed by cloud, they will not give you access for that. So everything they will do by their own. So but you can configure like how much, like how much you want to use, how much hardware you want. So over here, if you go ahead and change the plan, so based on that you will get the more features. Okay, so this is fine as of now. So as I said, with the platform as the service, you cannot change the underlying hardware, but you can change the configuration that is related to the specific hardware needs of a specific application. So if you go to overview and just scroll down, so you can see the, like if I just extreme scroll down, application inside. So okay, I don't have here because I haven't selected that. Oh yeah, here the monitorings. So you will get the monitorings here, like how many HTTP access was done, what is data in, what is data out, and what is the request and the uh, response time, like how many requests came as of now. So I just accessed it once. So you can see a spike here, and then what is the a response time. So it took around 35 seconds. So to answer my response, I mean to answer my request. So if you just scroll up, you can see the data out. So this is the, so 3 kilobyte of data it has given me when I try to access the URL of this application. So if you want more monitoring, like the CPU utilization, what is the memory utilization, you can just go and configure it. Okay, so this is the apps, the service, like we deployed the Docker container here. So do you have any doubt as of now?
The data transfer, like upload, downloads, and everything. So that is there any limit for that one, or we have to pay for that next? That data in data out, any bandwidth restriction or something?
Data translation. Here, data translation will not take place.
So data transfer, for example, like transferring data in and data out. Suppose the data transfer per monthly is crossing the any default bandwidth specification or something like that, or whatever.
Bandwidth,
Yeah.
bandwidth. Okay, okay. See, that's why. So, okay. See, in the scale out, so you have given the scale out option, right? Where it is, yeah. So that's what it asked you. So in the scale out, so you want to, so if what I can say, wait, let this go. So if you have chosen the basic B1 plan, so you can have up to the manual only. So you cannot go with the automatic, where it will scale the instances based upon the data, the coming in. Okay, so you have to change your this thing, the plan. So if you are doing if you are going with the premium or the any other plan, rather than basic one, so what it will do, so like as the data in, as the number of requests or the data, the input data is coming, based on that you can scale your instances. So according to that, I mean according to the pricing plan, they will charge you.
Okay. Okay.
Is it clear?
Yes. Yes.
Okay, so we saw the apps, the service now. On the next concept which we see is, okay, the micros services. So we'll see what are the micros services in the Azure. So in the last step, we started with the first platform as a service offering in Azure, which is Azure Apps, the service. There are a number of other platform as a service offerings in Azure, like around we have containers. So before we get to them, so let's try and understand what is a container and why do we need them. So one of the most popular architectural styles today is microservices. So all enterprises are heading toward microservices architecture. So here we are building small focused microservices. So can you please mute yourself?
Yes. Yes.
Okay. So here we are building small focused microservices. Like instead of building a large monolithic application, what we will do is we are building them as a set of small focused microservices. So the advantage of going for microservices is the flexibility to innovate. It's like you can build applications in different programming languages. So you can build the movies, the service in Go language. Maybe you can build the customer service in Java language. Maybe a review service in Python, and maybe these two, like the booking service and the fare calculations, the service, maybe these two I can build it in JavaScript. So obviously you don't want a lot of languages to be used in a single enterprise, but you always want the flexibility. So you want the flexibility to choose a different language if a need arises for a specific micros the service. But as you start building a number of small applications, the deployment for them become complex. Like you have to take care of many things. So if you have different ways of deploying the Go applications, Java applications, Python applications, and JavaScript applications, your operation team will have a big headache. It will have a lot. So your ops team will get the lot of load. I mean, they will get stressed from this because there is a different platform, and so the Go language, I mean the Go application will not run in the same platform where the Java will run. So they have to create a different platform for each microservice. They have to create a different platform for each application, for each language. So how do we have one way of deploying? So how we can create a one way where we can just dump all these Go, Java, Python, JavaScript, whatever it is. So how we can do that? So that's where the containers play a crucial role. So how do containers help here? So how do the containers help? So we would create a Docker image for each microservice. So whatever the a microservice is, so it is all present inside a Docker image, and your application runtime, if it is a Java application and your application is written in Java language, then obviously it needs the OpenJDK or the JDK to run that. So you can install, like you can make the JDK as a part of your Docker image. So if it is a Python application, you can make Python as a part of your Docker image. So it also has the application code and the dependencies. If it is a Java application, you have a .jar file. If you have a Node.js application, you have the package. So you have that also available as part of your Docker image. So if you look at it from a very high level, so VMs help you to virtualize the hardware. So you have a hardware which might be the single host, and you can deploy n number of VMs to them. So your VMs virtualize the hardware, and the containers on the other hand, they virtualize the software. So once you have a Docker engine installed in your VM, you can run any number of containers on the same host operating system. Okay, so for me, containers virtualize the operating system. So once you have a Docker image, you can run it as a container the same way on any infrastructure. So you can run it in your local machine, you can run it uh, uh, in your own environment, maybe the test. So you can run it in your corporate data center, and you can run it in the cloud as well. So if you just build your image and push it to your own a registry in your Docker hub, maybe wherever, or the ACR or any other or the Nexus. So from there you can pull it and run the container on any platform. So now what are the advantages of going for the Docker? So Docker containers are very a lightweight. So as I said, like as I said, uh, you can just push your image to any place, and you can opt any operating system, and I mean not the operating system, you can opt any hardware. Maybe you can run your container in your office laptop, or maybe you can run your container on your own local desktop. So it is very a lightweight, you can just ship your containers from one environment to another, or one host machine to another host machine. So virtual machines have something called a guest operating system. So however, Docker containers don't need a guest operating system, so they are a, a lightweight. So Docker also provides isolation for a container. So in each container you can run your mains, the service. So in this, as you see, the movie service, customers, the service. So for all this, you can create their own container, and to achieve the isolation, you are creating the different containers for each a service, and this container is nowhere related to this container. So if you are making changes to this container, it will not affect to this, the customers, the service. If you are doing any changes to fare calculation, so it is nowhere connected to the remaining services, it will not affect like that. So that's why Docker containers are used for the isolation, so it is very much important. Okay, so and then Docker is cloud neutral. So it is like, it is not like you can use the Docker in only cloud. So it is like you can run your Docker images on Azure, AWS, or Google Cloud, or any other cloud platform you would want to make use of. And it is not like you have your one image and you can have to just run on the Azure or only on AWS. No, it is not like that. You can run on any cloud. It is cloud neutral. So we just got a quick introduction to containers. So let's look at some important the services in Azure related to containers. So do you have any doubt here?
No doubt.
Okay. So
This containers, this Docker means that image can be Windows based or Linux based, anything. So that will support. So wherever you take it, so that will support all the any operating system whichever you have.
see, the images which are related to Windows operating system, they run only on Windows.
Okay. It does
See,
not. Yeah.
see, if you have something for a Windows, how I can say is, see, to install, if you're deploying your application on the, if you're deploying your Java application on the Windows, and for that you need to install the JDK. So the commands are different, right? So you will give in the, so when you write a Docker file, so when you write a Docker file, you will have so many instructions. You have a run instruction, you have CMD, you will be having entry point. So in the in those instructions, you have to give the commands which you use to install them. Okay, so to install the JDK in the Linux is different, and to install the JDK in the Windows operating system is different, right? So when you build the images, when you give the commands, if you are installing the JDK in the Windows, the command is different. And if that image, if the Windows image you are running for the Linux, and maybe that image will not get adequate, or the prerequisite, or it will not get the all the requirement or the pre-configuration to run that command.
Okay.
Okay. Okay, so we will see the different container technologies. So in this step, we will look at Azure container instances, like uh, so let's look at one of the important platform as a service offerings in Azure related to containers, which is Azure Container Instances. So Azure Container Instances help you to manage and run simple container-based applications, just like the apps service. So here you do not really need to worry about provisioning or managing your VMs. So Azure Container Instances can help you to start the containers in a few seconds. So one important thing to remember is that even with the Azure app service, you can okay, just give me a minute, I'm getting a call. Okay.
Okay.
Okay, so what we were speaking, like here we were discussing that we don't really need to worry about the provisioning or managing your VM. So Azure container instances can help you to start containers in a few seconds. So one important thing to remember is that even with the Azure apps, the service, you can deploy simple containers. We saw that, and that's what we did with the nginx. So Azure container instances makes it even more simpler to run a container. So it will even give you more options. Maybe it will give you a smooth environment to run your container. So let's quickly take a look at how you can use the container instances to run your uh, container. I'll just go to the, so this is also one of the app, the pass service, that is platform as a service. So I'll just go ahead and delete this. So just go to the here and search for the container instances. Okay, so you can just type in container instances in here. So container instances is what we have picked up. And I would want to create a container instance. You can just say create container instances. And you would see that creating a container instance is very easy. As usual, you have to select the subscription, and you have to select the like what is the a resource group you want. So I'll be going with the compute RG. That's fine for this. And the container name, I'll just give my first container. And I would choose the region as East US. That's fine. And then image source. So we will just pick up uh, the quick start images, so which is already built by the Azure and they have stored it. So we are not going with the Azure container registry here because we have not built any images as of now. So we will do that part in the DevOps part. So now, so quick start images, and let's use that, and which is provided by Azure, and let's use the size which is selected by default in here. So to run this container, so it is taking one virtual CPU and 1.5 gigabyte of RAM and zero GPUs. So and after that, like that's fine for us. We will go with the same size, and after that, going to the networking. So if you want to make it public, yes, you can just go ahead and do that. If you want to give your own DNS name label, if you have your own domain, so if you have purchased it, and you can just give it here. So if you want to, so as of now, yeah, the service, I mean whatever the service we will run on this container, it will run on the port 80. Okay, if you want to add any other port, you can just go ahead and do that. So if you want some to run on port 8080, so you can just go ahead and add the port 8080. So based upon your application configuration, you can do it. So next we can just say we can go to the advanced. So if you want a restart policy, so if the container fails for some reason, maybe it will not get enough resources, maybe the user might have done something that requires like it has dumped the more workload on the container that it needs the uh, resources beyond what we allocated to it. So at that time, your container will fail. So if you want to restart on the failure, you can just go with that. And like if you want to restart always, and if you don't want to restart at all, you can just go with the un never. So that's fine. And then environment variables, if there is any environment variables, like see, if you are running any SQL image or the database image, we have to give the root password. So without that, the container will not run. So if you have any other such, like the here you can give the MySQL root password and give the password for it. So you can just go ahead and do that. And if you want to encrypt anything, uh, by default, it will use the Microsoft managed keys. So that is MMK. If you have your own keys, okay. If you have your own keys, you can go ahead and say customer managed keys and give your own key there. So that's fine. So tags, if you want to give any tag, you can give. So I'll just go ahead and say review plus create. So it will run the final validation. If it looks good, so you can see the validation is passed. I'll just say create now. Okay, so our deployment is succeeded. So it took few seconds or few minutes, I can say. I can go to the resource. So our instance, I mean, our container instances are fine now. It is running. You can see that the status is running. So I can see all the details here. So you have the public IP address here. You can see the public IP address in here, and I'll copy this and launch it up in the browser. Just copy this and put it in the browser. So see, so it says, welcome to Azure Container Instances. We were able to easily deploy an application to Azure Container Instances. So over here, you can actually start, stop, and delete the container. So this page, whatever you are looking, so this page is coming from the a container. Okay. So now I'll just go here, and you can just start and stop the container. So as of now, the container is started. If you just go ahead and you can, if you stop, then you can no longer access like this. So it will just stop your container. It will stop your application as well. And also you can delete the container instance if you want. You can also look at the activity log. So like whatever actions were performed till now, you can see. And if you have many containers, you can see them. You can see all your different containers. So as of now, I have only one container. Okay, you can see. So these are the events happen. So first it is pulling the image from the Azure, that is the quick start. So once it has pulled, it has started the container. Okay, so if you want, if there is an issue, okay, you want just you can just go to like the logs and check. If you want to connect, you can just go to the connect and choose the startup command. So if you want, you can choose the bin bash or the bin sh. Okay, so we'll not do these things now. So we will do these things in the a DevOps part, like how to log in the container. If there is an issue, how to debug them.
So here we can connect to that container statement, right? Like to CLI.
Yes, yes, yes.
Okay.
Okay. So this is the container which we are making use of right now. So if you want to see the a metrics, you can go ahead and see the metrics, like what is the CPU usage, memory usage. So you can just click on this. And since the container is not running from the long back, it has run only for a few minutes, so you're not seeing anything here. So if you have ran your container for maybe 2 hours continuously or 3 hours continuously, at that time you will get this, the what uh, the metric, or the graph, I can say. Okay, so we will just go and delete this. We So next we will see what is the container orchestration, which is the next pass as the service. We will see that. So you have built the container images for your micros, the services. Just imagine you have built your images for your micros, the services, and you are able to easily run containers with them. So you have built a container for a microprocessor service A, B, C, and D, and now you would want to actually manage the deployment of these containers. You see, there are so many containers here. If you have so many services in your application, then obviously you will have so many containers as well. So if you have more than 10 to 15 containers, it is not humanly possible to maintain and monitor them by themselves. Okay, it is not possible. So you would want to ensure that you would be able to auto scale the number of the container instances that are running, like maybe based on the load, based on the metric, or based on some rule. So you might have a requirement saying that, like, I want 10 instances of the service A container and 15 instances of microservice B container, and so on and so forth. So just having containers is not sufficient. Like you would need some kind of an orchestration around these containers, and that's where there are a number of uh, container orchestrations, the solution. So what is orchestration? Just maintaining and monitoring, managing the containers is called orchestration, or having the control on those containers is called orchestration. So the most popular one, open source container, that is orchestrations, the solution, like when you are using this, like one second. Okay. So if you have multiple containers, you need a tool which can orchestrate it. So the most popular one, if you have heard about the Kubernetes. So the Kubernetes is one of the most popular open source container orchestrators, the solution. So when you're using this container orchestrator, the solution, you can say this is the container image for a microservice A, and I would want 10 instances for that. So this is done by the Kubernetes for you. Like if you say this is the microservice B, and I would want 5 instances of it or 15 instances of it. So the uh, container orchestration tool would manage the deployment of these containers into clusters. Okay, so each of these clusters can have multiple servers, and these containers are orchestrators typically offer a number of features. Like they will offer the auto scaling. You can say this is the container image for microservice A, and I expect a lot of load on that, so I would want to manage auto scaling. Like you can do that. So based on number of requests which are coming to microservice A, the container orchestrator tool will scale the number of instances of that specific container. And also you will get the service discovery, which is very important feature for the micros, the services. So you might have 10, 15, 20, or 100 micros, the services. Like you don't want to hard code the URLs of each micros, the service in another micros, the service. So that's where the concept of the service discovery comes into picture. So each microservice can ask the container orchestrator for the location of other micros the services. So let's say, so when we have the microservices, like see the application server, so just take the any social a networking application like Facebook, Instagram, any other like that. So when the user logs in to the application, so the first, so like you will be having the load balancer. Okay, so which will accept the request from the user and it will route the request to the application's server. So that is what we saw till now. So the same thing we will consider. We have a load balancer where the user a request goes, and from there the request goes to the application server. So when the request goes to the application server, it will give you the a welcome page. Like when you just access the Facebook, you will just get a welcome page where it will prompt for username and password. So that page is coming from my applications the server. So once you give the username and password, so application server, from where will it authenticate you? Okay, so how does it know that you are giving the right password and the username? How it will understand that you are the authenticated user? So that's where the application server will speak to another what another team which will take care of the authentication. Maybe when the user has created an account in the Facebook, at that time he has to give his details, he has to give the username and the password when we'll first create the account, and those details will get stored in the a, a database. Okay, so now when those details get stored in the database, when the user tries to log in the next time, so application the server will speak to the database saying that, hey, some user is logging into my application and he's giving the username and password. Can you please authenticate it? Can you please compare whether the username and the password is matching? So when it queries the DB, so how does it do that? So how does it application server knows where the DB stays? So that's where the service discovery takes place. So that's where the each the service will have its own allocation, or we can say it will have its own endpoint. So with the help of endpoints, the each the service will discover other microservice. So my application server will discover the database with the help of that endpoint. So that is called the service discovery. So this is very, very important coming to the the service applications. And thereby you don't really need to hard code the URLs. As soon as I start talking about the multiple containers, you need to also talk about the load balancing. So once I have multiple containers, I would want to distribute the load between them. So the container orchestrators also provide the load balancing. So you also want a, a resiliency. So if one of the instance of a microservice is not working properly, if it is down, then you would want the container orchestrator to identify that issue and replace the fault working instance with the healthy one. So you want the container orchestrator tool to identify the unhealthy instance and then replace with the new healthy one. So that's where you can configure the health checks, and the container orchestrator can execute frequent health checks and replace the failing instances. So that is called this self healing. So this is also called that is also called as the a good resiliency. So not only that, you can also want zero downtime deployments. Like let's say you are upgrading your application. So upgrading your application means in the backend you are upgrading the containers. Your maybe in the previously your application will have a, a v1 of, I mean it will be having the a version 1, and now a developer he had come and he had updated his code. He had added some more of features. So now he had updated his code, and the code given by the a developer has to be built. Okay, it has to be built and it has to be deployed in the container images. So the new built-in, I mean the new code which is written by the developer, so that code has to be built into some jar file or the var file. So we as the DevOps engineer, we do that. We build the uh, a developer code, we will build it to a jar file or the var file, and then we will copy to images, and then we will run the container from those images. So when we run the containers, so the application will run with the new features, because the jar file which is there in the container, that includes the new feature given by the developer. So when this happens, so you should replace the old containers with the new ones. So this you can do it. So with the container orchestrator will take care of this thing as well. So it will take care of the upgradation of the application. So when it does the upgradation, it will bring down the old containers and it will replace it with the new containers. So when this happens, so obviously we can expect some downtime there. Okay, so but with this container orchestrator tool, you can expect the zero downtime deployments. You can release new versions without any downtime. Okay, without any window time like that. So do you have any doubt as of now which we discussed?
This tool will use the features of auto scaling and load balancer of Azure, or this tool itself have the features for doing this one.
Okay, see, if you are using Kubernetes by yourself, okay, so you have your VMs, you created the VMs, and in that you have installed the Kubernetes, you created the cluster by your own. So at that time, the we have something called as the uh, a replica set in the Kubernetes, which is responsible for the auto scaling. So if you have told that a replicas, I need four uh, replicas at that time, it will take care of this the self-healing or those things. So but if you go with this, the platform as the service, that is the pass where you just configure the thing. So at that time, or auto scaling will be taken care by this tool.
Okay, okay.
Okay, uh, okay, so what's the time? So 9. Okay, so I can go ahead and show you how to create the AKS cluster, but there is a time constraint now. So shall we continue tomorrow? Is that fine for you?
Yeah, yeah, it's okay, no issues.
Okay, so tomorrow we'll see how to like I'll just show you like how to do that, and then we will start with the serverless,
Okay,
and we will start with the SaaS and the serverless, and then we will go with the databases, and then we will go with the I mean this the storage, we will go with that. Okay, so maybe next couple of weekends I need to complete this Azure administration, and then we can go with the Azure uh, DevOps. So everything you will see in depth there. If you just
okay. And tomorrow what time, ma'am?
a 7 a.m. because
Okay,
I will not having the night shift tomorrow, so I can log in by the 7 a.m. So see, this is the Azure DevOps, so where we will create the pipelines, the release pipelines. So and then you will see the Azure the container registry, where you will build your own images and you will push it there, and in your pipeline you will give that stage where it will pull from there, and then it will deploy in the AKS node pool. So we will see all of them. So see, I cannot take you directly to this concept. I have to give you some basics. So when I give you the basics, when you know the concepts already, so when I do these advanced concepts, you will get the the connection over there. So you will have you will be able to uh, relate at that time.
okay,
So we have the virtual nodes, the namespaces. We'll see what is the ingress with the external DNS, how to give the external DNS for your ingress, or how to take the internal DNS. We'll see that, and then we have so many concepts like that. Okay. Okay.
The last week's lectures, we have the notes for that. So just go through that last week.
Yeah. I'll send you that. Give me some time. As I said, this month I'm completing night shift, so I
Okay,
am
okay.
not able to concentrate on this batch. So don't worry, I'll give you. Okay.
But basically, you work from home or you have to go to office?
No, actually, this per week I have to go to the 2 days to the office. So since I'm in night shift, I am not going. So yesterday itself, I just gave the visit to office. I just stayed for 3 hours there because our mm, um, minimum to stay is the 3 hours. So if we stay for the 3 hours, they will consider that day as working in the office.
Okay.
So how you are doing? So you are working from home or the hybrid or you are going to office?
It's sort of hybrid sort of.
Okay.
Yeah.
Okay, Praveen, thank you so much. We will connect at the 7 a.m.
Yes,
tomorrow.
yes. Yes, yes, sure. No problem.
Thank you, Praveen. Thank you so much. Bye bye.
Thank you. Bye bye.
Okay.